Okay, so this is the part 2 of this solving this. So to approach them. After that, how to decode and solve this. So in this question, let us see here, we have a main function. With this we have string. In this they have given string of 0. The string also starts from 0, that means it is a character array that stores a string. So in this, if you are using indexing, if you use 0, 0 is the first element. For that we will be getting the value of t here. So let me open notepad here. So here the ASCII value of t is 84. So we have to convert this 84 into binary. So that's when we can calculate this XOR value. So the 84's XOR value is 01, 01, 01, 00. So this is the binary value of 84. So we have to XOR this value with 32. So here let me take 32 here. So in this 32, so the binary value of 32 is 00, 1, 00, 000. So this is the value of binary value of 32. So we have to do XOR. So XOR is nothing but we have to compare these same digits above them. If both of them are same, we will return 0. If both of them are different, then that means we will return 1. That means the value have to toggle 0 to 1 and 1 to 0. So let us check it. So the first value is 0 and 0. So it is 0. So the second digit is 1 and 0. So it is toggling. So we will give 1. So after that it is the third value also changing 0 to 1. So that means we can give 1. After that 1 and 0 again 1 and 0 and 0. So 0 and 1 and 0 is changing. So we will give 1. After that 0 and 0 is 0. So this is the final binary value. So if you convert this value, you will get 116. So what we are doing is we are printing the string. So that means it will convert it to the character again. So in that time, the value, if you print this as a character, you will get small t here. So let us check it. So before that, I will copy this code and paste it here. So let us run it. So we got toggle this first value. Okay, that means we have already seen this 32 is the difference between two uppercase to lowercase. For example, let us see here. In here, in this, for example, if I take A, the ASCII value is 65. And for small a, it is, if we subtract both of them, that means the difference between these two characters is 32. So here also we are XORing with 32. So that means we are toggling the case from upper to lower. So let us see the question here. So see here we are toggling the value and we are changing the first character of the string from uppercase to lowercase. If it is in the lowercase, then that time it will be changed to uppercase. So let us try to test it here. So I'll change this capital T to small t. So let us run it. So we got capital T here. So that means we are toggling the value. So can we change this S to uppercase? So that time we will know. So I'm using second index, that means the S character is the third value. So see here the S is being capitalized. So that means if you are using XOR value to a character with the value of 32, the lower case, if it is lower case, it will be toggled to uppercase. If it is in the upper case, it will be toggled to the lower case. So let us move on to the next question. So in this question, let us see here. It is a string array. That means the character array. It is named as str. So in this, I can say it is a string. And what they are doing is they are doing size of string -1. So that means the size of the current string -1. So let us see how it's working. Control C and I'll paste it here. So see here 1, 2, 3, 4, 5 and you may see it is 5, and if you are doing 5 - 1 it is returning again 5. So what can be there? So what it's doing? Okay, so let us see in the notepad here how it's stored in the array. So for that, see here, first a string should be like this, H, after that E and L, another L, after that O. So this is the how it's being stored in that. But one more thing will be stored here, that is the value of null. So null is nothing but =0. Okay, this is null. So this null will be stored additionally with every string. So it won't be point to anything to the next value. So that's why we are storing null here. So if you use size of, so it will return this extra value as well. So that time we have to reduce it by 1. So when you do that, you will get extra 1 value. So that's why we are doing this. So let us run it. We got pi here. So if I reduce it, I'll get extra size by 1. So that's why we are using -1. So this program is nothing but getting the size of a string. So now let us move on to the next question. So let us see, this is the question. In this question, there is a pointer string that is being used with this string code. So the pointer is usually starts from the initial index 0. So here it is C. That means 67 in the ASCII value. The ASCII value of A is 65. So B is 66. After that the C is 67. So pointer of, that means this value 0 plus 2 means it will point to this value. So it will move on to D here. So the current pointer is pointing to here. Okay. So first the pointer will be in 0, then 1, then 2. Because you are adding the current pointer 0 plus 2, this pointer will be pointing to this character D. So in this D, currently this is pointing to character D. So the ASCII value of D is 100. So what you are doing, you are adding plus 2 values. So D F, that means you can simply say after D, F, D, E and F. So that means you will be directly getting F as the final output. So because the value of 100 plus 2 will become 102, so the ASCII value of 102 is F. So F will be printed. Okay. So now let us try to run this. So I am running it again. So I got F. So what if I give, instead of this, I am giving info techies. So see here, initially this pointer will be in the first index, that 0th index, that means the first element in the string. So it will move on by 2. So that means it will move on to n. and after that f. So if I add f plus 2, I'll get h, correct? Because 102 plus 2, it is 104, then I'll get h. So let us try to run it. So I got the value h as the output. So if I try to change this to, I want to change this t, okay? So it is 0, 1, 2, 3 and 4. So I'll change this to 4. So instead of t, I want some other value. For example, I'll doing minus 2. So if I do that, it will be get back from two values. So it will get back to r. So we are getting r here. So this is how, this is the pointer. It will be always starts from the index 0 if you are not giving any pointing value. So if it means if it is in the fifth value and the fourth index. So after that you are reducing this value. So based on the PEMDAS or BODMAS method, the precedence will be always get among with this. This parenthesis is the for most condition that we have to satisfy first. After that we have to move on to the next questions. That means the exponential. After that multiplication and division. These both have the same precedence. If they have two same values, then that time you will be go from left to right. So after that addition and subtraction, these also have same level of precedence. So let us move on to the next question here. So this is the question. So this is the character array, that means it is a string. In the string we are having a ABC. So the index starts from 2, that means 0, 1, 2 is the last element. So greater than or equal 0 and minus minus, that means it is iterating from last to the first element. So in that what they are doing, they are adding the value by 1. That means it will become C plus 1 will become D and B plus 1 become C and A plus 1 become B. Okay, see here D, C, B. Why? Because let us see here. So in this, first initially the value of I is 2. So let me check 2 is greater than or equal 0. So it will return true. So it will return true. So if it is true, I will get into the loop. So now what will happen? I have to print the current character of I. So the current string of 2, and after that the string of 2 is the character C. So the character C's ASCII value is 65, 66 and 67. That means it can be said as 67. So 67 plus 1 is 68. So now the ASCII value is 68. That means the ASCII value of 68 is the character D. So this is the character that is being stored in here. So D will be printed in the output console. So in this output console, first D will be printed. So after that I will be decremented by 1 because of this decrement operator. So I will be 1 and 1 greater than or equal 0 is true. So now string of 1 is B here. So the B value is 66. The 66 plus 1 is 67. So the 67 ASCII value is the character of C. So C will be printed here. So after that I value will be decremented by 1. So 0. So 0 greater than or equal 0 is true because 0 equals 0. So after that string of 0 is the first element, that is A. So 65 plus 1 is 66. So here we'll get 66 here. So the value of 66 is capital B. So then B will be printed here. So this is how the iteration works. So let us try this in the compiler to check the output here. So let us run it. So we got the output D, C and B. So let us move on to the next question. So this is the next question. In this question, they have given a string, that is the character array, and they are using a pointer to the string. That means it is initially at the 0th index. So they are saying that while pointer. So here they are saying while pointer, that means the pointer is there. Until the pointer is there, it will work. After that, if pointer is equals L, okay, if pointer is equals L, then the pointer will be pointing to the character of capital L. So in this, what is happening? While pointer will do from initially from starting point last value, it will become 0. So when the value of 0 will be given inside it, so it will become false, then the loop stops. So this is how this loop works. So let us see here. So first h will be given in this value. So see here, while h, that means it is not 0. So then what is happening? Before that, I'll use the string here. So string equals hello, and after that a null value. So I'll place it with some 0. So we'll get to know how it is working here. So in this first index, it is h will be given here. So it is true. So I'm giving it as true. So after that, it will get inside the while loop. So here h is equals character L. So if it is h is equals L, that means I have to give some condition, but it is currently false now. So I'll mark it as false. So it will not get into the loop. So even though I'll write the condition here, what we have to do, we have to change the character, the current pointer to character L. That means the capital L. So after that, every time we have to increase the pointer here. So after that, we have to print it. After the while loop, we will be printing this. We will be printing the string. So now we have h, and it is true because the value of h will be some value other than 0. So after that, h equals L is false. So it will move on to the next character. So E will be in the while loop. So it is true. After that, E equals L is false. So it will move on to the next iteration. In this, L will be there. In this, if L is equals L, the ASCII value is both L have same value. So it will become true. So the current pointer pointing to this value will be changed to capital L. So the string will be, the small l will be changed to capital L. So after that, this L will be moved on to the next value, that is also small l. So it is true, L equals L is also true. After that, this pointer pointing to this current character will be changed to capital L. So after that, it will move on to the next value, it is 0. So in this, it will become true because 0 is also not a, O is also not a 0. So that means while true, then it will get into the loop. In this, O equals L. So it is false. So that means it will not get into the loop. So it will not change the value. So we got hello with capital L's. So if you print it, the output should be like this. So this will be the output if you are doing this. So let us see what the output is. So it is showing the same output. So let us try to print it in the compiler. So let us run it. So we got the output L. So if my pointer is, if I want to change all of the, for example, if I give info keys. So now I want one condition. I have to capitalize all of the Z in the input keys. So if I change this value, so let us run it. It should be capitalize all of the Z. So it is capitalize all of the Z in that. So or else I can do one more thing, that if I do else if here and again choosing the pointer equals I want to change small I to capital I. So that time I'll change the small I to capital I. So let us run it. So I got I and Z all capitalized. So this is how you will be capitalizing a specific character in a string. So this is the question they have asked here. So let us move on to the next question. So in this question, they have given a string with numbers. So in this string, they have initialized at the point of 0, 1 and 2. That means this 3. Okay. So this 3, after that, they are multiplying it and they are changing the value by converting it to a number. So see here, this 3 is a string. Okay. Then if it is multiplied with 2, that means the ASCII value will be multiplied by 2. Okay, because this 3 of the 3 is, wait, let me check here. In this we have string. In this string we are storing the values 1, 2, 3, 4, 5. So in this string, see here there are numbers and all of the numbers in the array are characters, like 1, after that 2, then 3, after that 4, after that 5, after that a null value. Don't forget this null value in a string. So if we do this, will be like that. So this is how the string will be stored in this character array. So now we are getting string of 2. That means this index of 2, that is nothing but the value of 3. So let us see here. The character 3 have the specific ASCII value. Okay. So let us try to guess it. But before that, you can see that the character of ASCII value is nothing but 51. Okay. In this 51 is multiplied by 2. So then that time we will be getting 102. So if you multiply 51 with 2, so we will get 102. So the 102 will be minus with 0, the character 0. If you get the character 0, that is nothing but 48. So 102 minus 48. So that time you will get 54. So in this, if you are using 54 and the character should be 6. So let us try to run it. So this song. So let us copy this. So we will get 6 here. So let us run it. So we now got value 6. Okay. So let us get back here one more time. So what this code having is the character 3 is 51 ASCII value. It will be multiplied by 2. So we will get 102. So we will subtract this with the character 0. The character 0 having the ASCII value of 48. So now we will get the ASCII value 54. So if you want to get the ASCII values, you just have to change this C to D. That means the integer. So now we will get 54 here. So now we got the value 54. So if you want to print the character, you will just change to C, that is character. So we will now get the value 6. So that's up for this problem. So we will move on to the next question here. So in this question, see here, they are given a string Zoho. In this string, we will be starting from 0 and ending at 3, because it is 3 less than 4, it will be true, then 4 less than 4 will be false. That means this loop will be run only 4 times. There are 4 elements here, so it will move on to each and every character in this string. So in this string, what they are doing, they are simply printing the values. But here, one more thing is there, they are doing %d here. So that means instead of we are printing the characters, we have to print the ASCII value. The ASCII value of Z is 90 and O is 101. After that, H is 104. After that, O is again 111. So if we run it, see here, we are initially starting from Z. So the Z value is 90. So 90 will be printed. So after that, we are giving some space here. So 90, after that, we should give some space here also. So after that, O, the value of O is 111. So 111 will be printed here. So after that, H, so the value of small h is nothing but 104. So 104 is printed here, and again O. After that, we will get value 111. So we'll have to print 111 here. So this should be the output of this problem. So let us see. So this is the output. So let us run it in the compiler to verify it. So let us run it. So now we got the value, that is 90 as the character value of Z, and 111 is for O, and after that 104 is for H. So we got the ASCII values. So make sure to verify every printing statement having character or digits or some values. So that time you will be confused by that. So don't do that mistakes. That's why the Zoho doesn't give any choose the best answer options. Instead of that, they have given fill in the blank. So let us move on to the next questions. So this is the question. In this, they are given a string. But see here, they are given a pointer. That means it will be pointing to the first index. So in this string, the character of 0 is nothing but t. So let us open my notepad here. So in this string, we got string of 0. That is nothing but capital T. So the ASCII value of capital T is 84. So if we convert it to binary, because we are doing XOR, so we have to calculate with binary values. So I am converting it. So we will get 0, 1, 0, 1, 0, 1 and 00. So this should be the value of 84. So after that, they are XORing with 32. See here, we are getting 32 here. We have already seen two problems with using this, because last time we will be subtracting or adding with the 32. That time we will be converting lowercase to uppercase. And once we have used XOR operator to convert the toggle the case of the character. So now let us try to run using this OR operator. So in this OR operator, so we will get the value of 32. So we'll check in this 32. The value of 32 is nothing but 00 and 1 and 0000. So this is the value of 32. So let us try a horizontal line here. So let us calculate it. So in this, if you are using OR operator, if any one of them is 1, that means it is 1. Or for example, we know that if true or false, it is true. False or true is true. False and false only false. That means 0 and 0 only 0. Other than all will be 1. So there is both of 0. So 0. After that 1. Because 0 and 1 is there. Another one is there. Another one is there. And both of them are 0. So 0. Then one of them is 1. So it is 1 and 0 and 0. So this is the binary value we have calculated using the OR operator. So if we convert this, we will get the value 116. So you may ask how to convert it. See here, this last digit is 2 power 0 and this digit is 2 power 1 and 2 power 2 and 2 power 3, like that it will go. So here we can say it is 0, sorry, 2 power 0 is 1 and it is 2, it is 4 and it is 8. So let us calculate here. So we will move on from the reverse. We have to calculate from this reverse. So this 0, so will we get 1, after that 2, after that 4. If you are having 1 here, we have to add it. So 4 plus, and 8 is 0, so we will not add it. After that 16. After that 32 here. After that 64 is here. After that it is 0. So if we calculate it, 64 plus 16, it will be 80, and after that 32 will be 112, and 112 plus 4 is 116. So now we got the value. So this is how we will be converting binary into normal numbers. It is 1, after that 2, you have to multiply it by 2 times. 2, how many times there are? It is 1, after that 2, then 4, 8, 30, 16, 32, 64, 128 and 256, like that it will goes on. So this is how we will be converting binary into normal digits. So we have calculated the value 106, but we are printing the character. So the ASCII value of 116 will be small t. So what we are doing here, again we are toggling the case. So let us try this code on this compiler. So let us copy it. So I am pasting it here. So let's run it. So we got the value small t here. That means I am toggling the value. So if we use small t here, we should be getting capital T. So it's not. So if you are using OR operator, so then the capital case will be converted to small case. Okay. So capital case is converted to small case here. So let us run it. So one more project I will create here. Plus after that the executable library, then create. The project is created. So now let us wait for a minute to build it. So change the code to run it. So we got small t here. So that means it is converting capital case to lowercase. So if we are using capital A here, it should return small a. So it is converting only capital case to small case. But here if you use XOR operator, so let us try to run it. So I am using capital A again. So you are getting small a. But if you are using small a, now it will be converting it to capital A. So if you are using XOR here, it will be toggle the case. But if you are using only OR operator, it will be only converted to smaller case. So let us move on to the next problem. So see here, this is the question. In this question, what we are doing? String 2, string of index 2, that is the last digit C, and string of index 0, 1, that means the first index. So what we are doing? Let us remove it. So C minus A. So 99, the value of C is 99 and the A is 97. Okay, now we will get 2. So they are printing number here, so there is no problem. 2 will be the output. So the 2 will be the output. So let us run it. So we got the output as 2. So let us move on to the next question. So this is the problem. In this problem, they have given a string and there is a pointer with the fourth index 0, 1, 2, 3, 4. That means the last element in the array. So what they are printing? They are printing the pointer element minus 3. So O minus 3 is the character. So we know the value of O is nothing but 111. So the ASCII value of O is 111. So 111 minus 3, we will get 98. So we should get 108. So in this 108, we will get some value here. So the value of 108 is nothing but L. That is small l. So the output should be small l. So let us try to print it. So you may ask the question, how can I memorize these ASCII values? So basically remember the main ASCII values. Those are capital A for 65 and small a for 97. So this should be enough. After that you can just simply calculate it by one like that, the character value from A to Z. So you can add it and you will get the value. So let us try to print it. So it should return the output as L. So let us give some another examples here. So we are changing the last digit, so there is no problem. So we should at least give 5 digit values. So because it is pointing to the fourth index. So for that I'll give like this. So the fifth value is small a. So small a minus 3 will return some special characters. So it is returning the XOR operator. So let us move on to the next question. So this is the section 4. In this we will be fully seeing bitwise operators. So see here, this is the problem. In this problem, the value of A is 13. Okay. After that, the value of B is 7. So again we are using XOR operator, as we already know how to calculate it. So before that we can simply use 13. In the value of 13 is 1101 and the binary value of 7 is 0111 because 1 plus 2 3 plus 4 is 7. So here 1, there is no 2, 1 plus 4 is 5. After that 5 plus 8 is 13. So we got the value. So in this we have to do the XOR operator. As we know, if the value toggles, that means the value can be 1. If it is not toggling, it is 0. So 1 and 0, it is toggling 1. 1 and 1, it is same value, so 0. 1 and 0, again toggling, and 1 and 1, it is 0. So most of the people know that this is a famous bitwise binary number, that is 1010. You may already guessed it, it is nothing but the value 10. The 1010, there are two 10s will be there. If this is the value, you can simply say it is 10. For alternate, one more thing is there, that is 0101. If you see this number, you can blindly say it is 5. So let us check it. If you are using this code, so the value should be 10. So let us run it. So we got the value 10. So if I do same value, for example 1 and 1, I'll always get 0 because both of the digits will be same. So if I use same numbers like 34, 341 and 341, I will again get 0. So let us change this number. So let us check what number it's returning. So it should return some values. So this is how we will be doing XOR operations. So let us move on to the next question. So in this question, we are doing right shift. So most of them would already know that how to do that right shift and left shift. In this previous live video, we have already done that. So again, we will be doing it. So we got the value of x is 16. So we have to do right shift operator. This is nothing but the value n. So if you are doing left shift, what you can do, x power x is multiplied by this number by, that is 2, and power after that this n. This is nothing but n, so I am using n here. This is for left shift operator. And if you are doing right shift, x divided by 2 power n. So that time you will get the right shift operator. So this 2 continuous less than symbol is nothing but the left shift, and this 2 greater than symbol is nothing but the right shift. So the value of x is 16 here. So we are doing right shift. So 16 divided by 2 power 3. So we know 2 power 3 is nothing but 3 times of 2. So 2 times of 2 is 4, and 4 times of 2 is nothing but 8. So you are dividing this 16 by 8. So that time you will get the value 2. So 2 will be the output of this code. So let us check it. I am copying it and pasting it in the compiler. So let us check it. So we are getting the value 2. So we will move on to the next question here. So let's see here. In this, we have a number 25, and after that we are doing that number not operator and adding 1. So it is nothing but 1's complement. So we will do the 1's complement here. So there is a one condition is there, that is nothing but if you do 1's complement to a number and add it with 1, the sign will be changed. Okay, so let us see here. If you let us see in the compiler first. I am copying it and pasting it here. So see here, there is a method, that is if you do 1's complement, that is not operator, and add it by 1, you will, the sign of the number will be changed. So if it is positive, it will get negative. So let us check with negative value. So it is positive. So if I do positive, it should return the output as negative. So it is returning the negative. So see here, there is nothing but the 1's complement. You will convert all the digits, and after that you will be adding by 1. So that time the sign of the number will be changed. So this is nothing but the 1's complement. So let us move on to the next question. So in this question, we have seen how to do 1's complement. With after that we have done add it by 1, so it will convert to the 2's complement to change the value. So here, if you do this 1's complement, if you add it by 1, it is 2's complement. Okay, so let me move on to the next question here. So in this question we have given the value of x with 15. So what we are doing, we are doing AND operator with a number and adding by the one number. So let us see here. So the value of x is 15. So the binary value of 15 is 0, 11, 11, because 1 and 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 8 is 15. So after that, the value of, we are doing it with 16, nothing but 15 plus 1. So x plus 1, so I can say x plus 1 is 16. So let us change this value. 16. So in the 16, I can simply say 8. After that you will multiply by 2, so it will become 16. So after that other will be 0. So what we are doing here, we are doing XOR operator, sorry, AND operator. So AND means true and true only true, or else all of them will be false. So let us check it. So 1 and 0. So even if a single 0 is there, it will be 0. So 0. So all of the digits have at least one 0. So that means 0. So all of the digits is 0. So you will get the output as 0. So we are printing the digits, so there is no problem. So let us see here. We should get the output as 0. So we got the output as 0. So let us move on to the next question here. So in this question, okay, if you have already seen the operators in the program, so you will be already knowing what this program is, because in this program we have already seen this. If you are not seeing that, go Mac and Store to check the video, because in that I'll be explaining it. It is nothing but swapping of the two variables. Okay, if you are using this, the value will be swapped. Okay, so now let us check it. See here what is happening here. That is A equal to A XOR B, B equal to B XOR A, and A equal to A XOR B. This is nothing but it will converting the digits and it will be swapping the variables. This is how we will be swapping the two numbers without using any temporary variable. There are also in one other method is there, that is addition and subtraction, and we can do by multiplication and division. But in that multiplication and division, there will be one particular error will be there. That is, if you are trying to swap with 0, then that time it will be a disaster. So most of the time we won't be using that value. So instead of that, you can do addition and subtraction and multiplication and division. So if you are seeing this kind of code, it is, you can blindly say it is swapping of two variables. So let us see. After that, I will explain it in the notepad. So run it. So we have changed the value of A to B and B to A. So let us see how it's working. So in this, first let us see, A value is 10 and B value is 6. So first we will see addition. So first what I can say, that A equals A plus B. So in that time the value will be stored with 16. After that B equals B, that is the current, sorry, A, the max greater value, minus after that B. So in this time what you are doing, 16 minus the current B 6. So you will get 10. See here, what is the value of A? It is 10. We got the value B is 10. So we have successfully swapped the value of A to B. So now we have to swap the value of B to A. So A equals the current value 16. So if I subtract this 10, we will get 6. So that means A minus B again. A minus B. So this time we will get 6. So see here, B is containing 10. After that, let me remove. So B is containing 10 and A is containing 6. But previously it is containing opposite. So that means we have successfully changed the value. Same goes for A XOR B and B equal B XOR A XOR B, like that. We can simply do this also. So there is no errors there. You can simply put this code. So you will get the same value. We are just alternating this A and B. So if I run it, nothing will be changed. The same code will be there. So 12 and 16, like that. The input what you are given in, it will be changed according to this code. A equal A XOR B and B equal B XOR A and A equal A XOR B. So this is the code. So let us check it. So 6 and 10 is swap. So this is what we are doing with the same code. We have swapped with this value, that is b equal to a XOR b, like that. So let us copy this and paste it, so we can check this code. So here I'll remove this, and after that this value and this value. So this is the code that we are used in the notepad. So let us run it and check. So it is swapping the value 6 and 12. So let us see 1 and 2 to get 2 and 1. So that means it is working perfectly. So we got the value and it is working perfectly. So let us move on to the next question. So this is the question. In this question, let me make a note here. So on this x value is 7. After that, count is 0. Then while, that means x, currently the value of x is 7. So what we are doing, x and equal to x minus 1. That means x equals x and x minus 1. This is what they are saying. So after that we have to increase the count by 1. So this is nothing but we are increasing the count. We are checking how many times the loop is running. So here first 7 and 6. Okay. So first let us calculate here what is the value of 7. That is nothing but we can say 4 plus 3 or 4 plus 2 plus 1. 0, 111, 1, 2 and 4. I can say it is 6. After that, for 6 it should be like this, 0. I can say 4 plus 2 is 6. So 110. So now if we check it, you will get the value 0, 1, 1, 0. Correct? Because these two values have the same. So this toggling will be also false and both 0 also false. So we will get 6 here. So the count will be incremented by 1. So now let us check here 6, after that 5. So for that 6 and for 5 it is 4 and 1. So this is the value of 5. So if we see here, this value only came, other than all will be false. So that time again this count will be increased. So current x value will become 0, 1, 2 and 4. So the current value of x is 4. So after that 4 minus 1 will become 3. So 0, 1, 00. So 3 means 2 plus 1. I can remove this 0 and make it as 1. So 1 and 2 is 3. So see here, all of them are different. So it will become 0 here. So the current value of x will become 0. So while 0 is false, then the loop will be terminated. So that time, what we can get is the output, that is 3, because the loop have been run 3 times. For the first time, it is 7 and 6. After that, it is first time it is 7 and 6. After that, it is 6 and 5. Now it is 4 and 3. There are 3 times the loop is being run. So the count is incremented 3 times. So 3 times the loop will be run. The fourth time it will become 0. Then it will be false. So let us run it. Copy it and paste it here. So let us run it. So the output is 3 here. So let us move on to the next question. So in this question, we have given two values, 12 and 5. So we already know how to calculate the R value. So let us do that once again. So x is 12. After that, we have to find the digits. That is nothing but 1 1 0 0. 8 and 4 is 12. After that 5. So for 5, the value of the numerator is x, it is c. So after that b equals 5 and the value is 0 1 0 1. Okay, now let us calculate it. So here we can say 0 and 1. We are using OR operator. If any one of them is 1, that is 1, 1, 1. They're both of 0, so 0 and 1. So 8 plus 4 is 12. 12 plus 1 is 13. So we are getting the value as 13 here. So let us see, it is 13. So copy it. So let us paste it in here. So now let us run it. So we should get the output as 13. So let us move on to the next question. So this is the program. So in this program, we have given the x value as 1 and we are doing left shift. So try to do it on our own. So let me make sure to wait for at least 1 minute so you can get it. So I have already said that the current value is, if you are using left shift, you have to multiply with 2 power of n. That means 1 is multiplied by 2 power of 5. So we have to calculate 2 power 5. So 2 power 1 is 1, 2 power 0 is 1, 2 power 1 is 2, and 2 power 2 is 4, and 8, and 16, and 32. So we have already know that it should be 32. So see here, so it is 32. Okay. So let us multiply it. So we can check 1 multiplied by 2 times 2 times 2 times 2 and 2 times of 2, it will become 2 times of 2 will become 4. So again 4 times of 2 will become 8 and 8 times of 2 will become 16 and it will become 32 and 32 times of 1 become again 32. So this should be the output. So let us run it. So let's paste it. So we got the output as 32. So if we change this value to 2, so let us guess it, because we are just already getting 2 power 5 is 32. So 32 times of 2, that will be the answer. That is nothing but 64. So we got the output 64. So let us move on to the next question. So this is the question. In this question, a value is 20 and b value is 15. So we have seen the AND operator. So we can calculate it. So I'll do it on my own. So if you want to check your skill, you can also check it. So we have to find the value of 20. So for 20, the value is 0 1, sorry 1 0, after that 1 0 0, because it is 16 and it is 4. 16 plus 4 is 20. After that 15 equals, so we know the value of should be 0 and 4 ones. 1 plus 2 is 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 8 is 15. So let's calculate it here. So 0 we are using AND, so both of them is 1, then that only is 1, other than all will be 0. So 0 0, both of them are 1, so 1 and 0 0. 1 2 4, so the output is 4. So let us check it. So the output is 4. So let us copy and paste it here. So run it. So we got the output 4. So let us move on to the next question. So in this question, they have given a hexadecimal value of 0xab. Okay, so let us decode it. The value of 0xab is nothing but 10 10 10 11. So let us try to calculate it here. 1 plus 2 3, and 3 plus there is 4, no 4. So 3 plus there is no 4 and 8. After that no 16 and 34. After 34 there is no 68, sorry 32, and there is no 64 and there is 128. So 128 plus 8 is 136 and 139. After that 169 and 171. So this is the value. So we don't need this much. We just need to know this value. So 0x 0f. So in this 4 zeros, 4 ones. So if we calculate it, so we'll know. So let me make it clear that these values are hexadecimal. In this hexadecimal, it will be 16 digits. So after 9, that means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After that 10 will be A, 11 will be B. Like that it will goes on. There is F. This F is nothing but 15. So this is the value of 15 here. So the 4 digits of 1. So after that, this is the AB. So you know that how to calculate it. As I said before, hexadecimal 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9 the 10 is A, 11 is B, and 12 is C, 13 is D, like that it will goes on. So that's how we have to find this binary digits. After converting number, you have to converting it to a binary digit. So let us do the AND operation. So in this AND operation, 0 and 1. So you know 0 and 1 is 0, 0, 0, 0, 1 and 1 only 1, 0 and 1, 1. So see here 1, 1 plus 2, 3, and 3 plus 8, it is 11. So we should get the output as 11. So let us copy it and I'll run it. So we got the value 11. So this 0x is nothing but the representation of hexadecimal digits. So this AB is the value and this F is the value. Okay. This F is nothing but 15. After that you have to convert this value of 16 power value that add it. So like that you have to do that. So let us move on to the next question here. So now let us see here. In this we have given a value A equals 9. So there are two operations here. That is, first 9 is multiplied by 2 power 1. That is nothing but 2. So it is 18. After that, for right shift, the left shift is this. So the second one is 9 divided by 2. So we will get 4. So we have to calculate it. Why? Because it will be like 4.5 here. But in integer division it is just 4. So we'll just use binary operation here, that is 1, 0, 0 and 1, 1, 0. Okay, 1, 0, 0, 1, 0. So here the 4 is nothing but 0, 1, 0, 0. Okay, so for that we have to calculate it. So I'll add 1, 0 before it. So basically how this works is, for example, the left shift and right shift is nothing but it is shifting one digit. For example, the normal value of 9 is 1, 0, 0, 1. So if you do left shift, that means this all value will be moved to left. That means you have to add 1, 0 in the right side. Okay, simple. It is 9. You have 9 value. If you are doing left shift, okay, left shift by 1, you will add 1, 0. So if you are doing right shift by 1, then you will add 1, 0 in the left side. Like that you will do. So if you add right side in 1, 0, this final digit will be removed. So that's how you got 4 here. Okay. If you do right shift, 1, 0 will be added in the previous value and the final value is, the last value is removed. If you do left shift, 1, 0 will be added in the right side. So this is how we got this value. So let us calculate the OR operator. Okay, for finding this OR, if any one of them is 1, that is 1, 1, 0, 1, 1, 0. So this is the value. So if you calculate it, you will get around 22. So this is the value of, this is the binary value of 22. So let us calculate it. So let's run it. So we got the value 22. So now let us move on to the next question. That is the 62nd question. In this question, they have given a value, x value is 31. And we have to do x and not x. Okay, this is not operator. So let us do that. So let me open this notepad. So the value of x is 31. So let us see here. In this, what we are doing, you are doing this value. So if you do that, you will get the negative value of that. So let us see. This not is nothing but changing the all of the zeros into 1 and 1 into zeros. So for 31, it will be like 0, 0, zeros, something like this. It starts from 0 and like that. After that, 3 zeros, triple 1, triple 1. So let us calculate it. 1, there are 5 ones are there. That is 1. 1 plus 2 is 3. 3 plus 4 is 7. And 7 plus 8 is 15. And 15 plus 16 is 31. So this is the digits. So then if you use negative operator, so that time the 0 will become 1. After that it is same like that. So when it becomes again 1 after zeros. If you do 2's complement, the final value only be 1. After that everything will be 0. So if you do AND operator, so now what is happening? Every zeros will be 0. The final output is a single 1. So that will be 1. Okay, what we are doing? We are doing 2's complement. If you are doing 2's complement, then that time this value, the zeros is converted to ones. Okay, so it may confusing. So let me remove this. This is how it's working. There are multiple digits are there. So zeros and ones. In the 2's complements, one will be converted into 0, and after that it is also converted to 0. So we have to add 1. So that time we will be adding this digit. Okay. So now while you are calculating this, you will get all of them as 0. This is the output. So you have to add the final digit with 1. So in binary digits, 1 is nothing but the last digit 1. So after adding it, you will get 1 again. So the 1 is the 1 should be the output. If you are using x and not x, so you will always get the output as 1. So let us see it. Let us copy and paste it. So what this will do is it will be isolate the rightmost value. So that time we will get 1. So let us see next question here. In this question, the value of A is 8. So we have to do right shift. We know that right shift is nothing but dividing it by 2 power 2. That is 2 power n. So 2 power 2 is 4. So 8 by 4 should return 2. So after that, you have to do right shift by left shift by 1. So multiply 2 power 1 as 2. So we will get 4. So it should be 4. So let us check it. So the output is 4. Let us try to run it. So the output is 4. See here we have seen left shift and right shift multiple times. If you are doing left shift, make sure the current number is multiplied with 2 power this value. This is nothing but n. So after that, if you are doing right shift, it have to be divided. Left shift, it have to be multiplied. Or else if you are okay with binary conversion, convert it to binary. After that, do the left shift by 1 digit or 2 digit if it is most value. After that, right shift. After that, calculate it by converting this value. So here there is a number 100. Okay, this is the number. So we have to multiply this number with 1. Okay, so let us copy it, because there is one thing in this code. So I'll explain it after that. Before that, we will run this code. So let's copy and paste it. If I run this code, see here I got 0. Okay, so now what happens? First, the value of A is 100. Okay, after that we are doing AND operator with 1. In this, there can be only 2 possibilities. One is 0, another one is 1. Why? Because the one having only 1 digit. The last one is the single digit. So if a number that is having a single, that one, that times it will return 1, or else it will return 0. Okay, it is also known as counting the even or odd number using the parity. Okay, if it is a even number, you will always get 0. If it is odd number, you will get 1. Okay, it is nothing but checking even or odd. If the parity is 0, it is even number. If it is 1, it is an odd number. So let us check here. For example, I am giving 105. So we got 1, so it is a odd number. So for example, I'm using scanf here instead of bit. So scanf in this code, I'm using ampersand x. Okay, now I have stored this value. So then I just need to check here. I'll just say x and 1. That means if it is even, because if 1 and only even, then only it will be execute. So I'll just print even number. For it's a odd number, so odd number, or else if it's written 0, then it will come to else case. So it is even number. So I should remove this. So let us run it. So I remove this parenthesis. So let us run it. So I have to give some input. So I'll give 12. It's a even number. So it's even number. So if I'm giving another number, so I am giving 1. It's an odd number. So if I give 0, most of the time 0 is given as even number. So it's even number. So some random number. So it is a even number. So see here, this is the parity check that is used to find even number or odd number. If the output is 1, so in that times it is nothing but odd number. If it is 0, it is even number. Okay. So now we got the value a is 14. So in this we are doing XOR operator with right shifting by 1. So that means right shifting by 1 means we are divided by 2. So a by, that means 14 by 2 is 7. So we are doing XOR operator with 14 and 7. So for 14, that is 1110, because 15 all 4 digits is 1. So if you are minus 1, so it is 14. So after that 7, that is 0 111. As you can see, we are removing this digit and we are removing this one digit and adding 0 before it. That is nothing but the right shift. So if we calculate it, what we are doing is XOR operator. So it should be toggle. So 1 0 0 1. That means 8 plus 1 is 9. So let us see the output here. So it is 9. So let us copy it and paste it. So see here, this is 14 and this is 7. So let us run it. We got the output as 9. So let us move on to the next question. So we have moving on to the next question, that is array and memory. There will be another set of 15 questions are there. So 65 plus 15. There are overall 80 questions. So we will be moving on to the next questions. See here, this is a 3 row 3 column array with having 9 elements in the values. This is row 1, row 2, row 3, row 1, column 1, row 1, column 2, row 1, column 3. This is how it have to be executed. We are using a for loop, 0 and less than 3, that means 3 times it should run. And what we are doing, we are summing the values, that means adding the values. Initially the sum is 0, so let me take sum is 0. So now array of I plus I, that means 0th index, 0th element. If it is 1, it will be this element. After that, if it is 2, that means this element. That means it is going on a diagonal way. For example, it should be like this: 1, 2, 3. After that 4, 5, 6 and 7, 8, 9. So 0 and 0 is this, and 1 and 1 is this, and 2 and 2 is this. This is going on a diagonal way: 1, 5, 9. So we are adding 1 plus array of I minus 2i. That means the current rows, 2 means this element. So for the first time, so let us see, first sum equals 0. So 0 plus the diagonal element, that is 1, 1 plus array of 0 and 2 minus 0 is again 2. So 0th row, second element is this diagonal 3. So that means I can say 0 plus 1 plus 3, that is 4. Currently the total sum is 4. So I will remove these lines. So it is getting onto the next loop. So the next diagonal element is 5, again 5 plus array of 1 and 2 minus 1 is 1, so 1. So see here we are getting this element, again 5. So I'll remove this and add 5. So 4 plus 5 plus 5 is 14. So currently the sum value is 14. So after that 14 plus this 202 is this value 9. So 9 plus, you may already guessed it, it is adding this diagonal element and this diagonal element. So array of 2 and 2 minus 2 is 0. So this element 7. 14 plus 9, that is 23. 23 plus 7 is 30. So the output is 30. Okay. See here. This is the main diagonal. This is the main diagonal 159, and this is the anti diagonal, that is 357. So we are adding these two diagonals to get this value. So let us run it. I am copying it and paste it. So let us see here, we got the output as 30. So now let us move on to the next question. So in this question, we will be seeing about pointers as well as the array. So in this array, it's a 1D array. 1D is nothing but one dimensional array. We have 1 rows and n number of columns. In this there are 5 columns there, that is nothing but 5 values: 10, 20, 30, 40 and 50. See here, we already know that the pointer will always starts from 0th index. We are doing array plus 2, that means 0, 1, 2. It should be pointing at the value 30. So 30 plus 2 of array. So this is where most of them would confuse here, that it is pointing that 2 of array. So what is this 2 of array? Okay, this 2 of array is nothing but array of 2. Okay, this 2 of array is nothing but this array of 2. So this array of 2 is same 0, 1, 2 and 0, 1, 2. So 30 plus 30, it is 60. Okay, this is nothing but the representation of array of. So let us copy it and paste it. So then we will see if it is working or not. So let us run it. So we got the value 60. So let us move on to the next question here. So here it's again a 2-dimensional array with 2 rows and 3 columns each. In this, first let us see how it's internally stored. So for that, 1, 2, 3, and 4, 5, 6. Okay. This is how it stores. 0th row, see 0th row second element. 0th row second element is 3. Second means the second index, that is the third element, it is 3. So we'll add 3 plus first row 0th element, it's 4. So 3 plus 4, it's 7. So let us see, the output is 7. So let us copy and paste it. So in here we have see that. So let's run. So we got the output C 7. So let us move on to the next question here. In this again pointers. So currently 0, 1, 2, 3. Currently the pointer is pointing at the first element, that means the first index 10. Okay. In this we are adding P of 1 means we are adding the current index plus 1. So that means the current index is nothing but first index. So P of 1 plus 1 is 2. So that value is nothing but 15. So the current index is 1. So 1 minus 1 is 0. So minus 0. P of 0 is nothing but 5. So what we are doing, 15 minus 5. 15 minus 5 is 10. So the output should be 10. Okay, let's copy and run it to verify the output. So let's run it. So we got the output at 10. So let us move on to the next questions. So in this we got the one dimensional array with the size of 4 with 4 elements. So we have to calculate it based upon that. In this they are asked us to print array of 2. First we have to calculate the innermost value. The innermost value is array of 2. So the array of 2 is 0, 1, 2, that is 3. So array of 3 is nothing but the final element, that is 4. So if you print it, we will get the final element 4. So see here it is 4. So let us calculate, run it in the compiler to verify the output. So let us run it. So let us try one more values, like for example if I change this to 2 and after that I'll change this to 10. So it should be like print array of 2 is 0, 1, 2. So 2, 0, 1, 2. So it should be remain the same. So it should print 2. So it is printing 2. So let us change this value by adding some more values. So I remove the size. So I am adding some values. So some more value. So I am just changing 0, 1, 2 as 4. So we got the output 4 because 0, 1, 2 it is 4. Again 0, 1, 2, 3, 4 is also 4. So let's change to 67 here. So the output should be 67. So we got the output 67. So let us move on to the next question. So in this question, it's again a two-dimensional array. In this array, 3 rows, 3 columns. So first let us visualize the array. So 1, 2, 3 and 4, 5, 6 and 7, 8, 9. So this is the array. In this array, we are using a pointer here. Array of 1 plus 2. Okay, this is where it gets critical because they have given a single value. Okay, array of 1 plus 2. It is what they are asked us to print here. So this array of 1 is pointing to this array. That is nothing but this 4, 5, 6. So in this 4, 5, 6, what they are asking us to get is plus 2. So this plus 2 means nothing but this expression can be break down into array of 1 and this plus 2 will make this as the column 2. Okay, this array of 1 plus 2 is pointing, this is a one more pointer. You know the index is starting from 0. So 0 plus 2 will point to this value. That means 0, 1, 2. The last value is 6. So if we try to print it, we will get the output as 6. So let us try to run it and verify the output. So run it. See, we got the output as 6. So now let us move on to the next question here. So before that, we will check some more variations. In this, if I give 1, I should get the output as 5. So let us try to run it without adding anything. So see here, if you don't add anything, okay, just pointer array of 1, you will get the first element. Defaultly, the second column will be chosen the 0th element, first one. So if we try to do in the second index, that means this array, we will get 7 as the output. Okay, let us move on to the next question. So in this question, we got a one-dimensional array. In this, they are saying 2, within that they are given the array. That means 0, 1, 2, 300 plus 0, 1 plus 2, 500, 200, 500. So we got the output 500. This is nothing but the expression of array of element 2 plus array of element 1. 0, 1, 2, 300 plus 200. We will get the output as 500. So let us check it. Copy and paste it in the compiler. So we got the output 500. So let us move on to the next question here. So in this question, let us see, there is a one-dimensional array with the size of 5. In this, the pointer is pointing to the value 0, 1, 2, 3. Okay, it is pointing to the value 3. So now we have to calculate the value. So in this value, they have given us 2 pointers and we have adding it by adding and subtracting. Okay, let us see here. In this 0, 1, 2. Okay, this value is stored as a pointer value 0, 1, 2, that is 3. So 2 plus 1 will be 3. Okay, that means array of 3 is nothing but 4. This is the index 0, 1, 2. 2 is the pointer. So 2 plus 1 is 3. This is pointing to 4. So let me write it here. The current pointer is pointing to the index of 2. So the 2 plus 1 is array of 3. Because 2 plus 1 is 3. So it is pointing to the value 3. So array of 3 is nothing but 4. So after that we are subtracting it by 1. So array of, again 2 minus 1 is 1. So we will get the output as 2. So we are adding it. So 4 plus 2 is nothing but 6. So let us run it. So now we got the output as 6. So now let us move on to the next questions here. So this is the question. It's a 2-dimensional array with 2 rows and 2 columns. First let us visualize the structure of it. So for that 1 and 2 and 3 and 4. So this is the structure, and the first pointer is pointing to the 0th element and 0 row 0 column, that is nothing but 1. So what we are doing, pointer plus 3. So we are adding the current pointer plus 3. So that time, see here we should get pointer plus 3 means 0, 1, 2 and 3. Okay, 0, 1, 2 and 3. So that time 0, 1, 2, 3 we will get the output as the final element 4. It is nothing but array of 1 of 1. So that is what it's mean. It's 0 of 0. So let us try to run this code. Let me copy it and paste it in the compiler. So run it. So we got the output 4 here. So see here, if I just give just p, in that time I'll get 1 because it is pointing at the 0th index. So that time I will get 1. Okay, now because we are initializing the value with the address of the first element. So if you are adding 1 by 1, it is move 1 by 1 steps. So that time it will move according to it and it will finally reach this final element and print the output as 4. So let us move on to the next question. So this is the question. In this question, see here, there is a one-dimensional array. So in this one-dimensional array, we have 10, 20 and 30 and we are using the size of array. So there are 3 elements. Okay, there are 3 elements and it will be like each element will have around storing 4 bytes. So that time we'll get the size around 12. So let us try to run it and see what is the output. So run it, we got full. Why? Because most of them we are using 32-bit systems. Okay, in this value have 4 bytes, this value have 4 bytes and this value will have 4 bytes. So all of them in the sum of it will get 12 bytes. So if you actually want it, what you have to do, you have to divide this with the first element in this array. So that means it is 12. After that 12 by 4 will return 3, the actual size of this array. So if I try to run it, we got the actual size 3. So make sure we are using, if you using just size of the array, you will get the bit size of the array. So if you want to actual size, you have to use size of, you have to divide it by size of the first element in the array. Okay, let us move on to the next question here. So in this question, there is a one-dimensional array with 3 elements. Currently the pointer should be pointing at the first 0th index, first element, and adding 2 will 1 and 2. So that time it will point to the last element 15. So first the value is 15 plus the current pointer is pointing to 15. So reduce by 2 times, it will move on to the 5. So 15 plus, it's negative, so 15 minus 5, it will give the output as. So let us see here the output is. So let us try to paste it in the compiler. So let us run it. So the output is 10. So now let us move on to the next questions. So in this question, I have given a one-dimensional array and we are adding 0, 1, 2, 3, 4 and it is also the same. See here, array of 3 is same as 3 of array. This both of them are same. In C programming only it is accessible. C and C++ it is accessible because array of 3 equals 3 of array, it is accessible in the C programming, so it won't throw any errors. So you have to convert this to this, so that time you will get the same value, that is nothing but 4 plus 4, it should return the output as 8. Okay, now let's take a look at this. So the output is 8. So copy it. Let me paste it here. So I'm running it. So we got the output as 8. So now let us move on to the next question here. So in this question, we got a two-dimensional array with 3 rows and 3 columns. In just adding among with the elements. So array of, so first let me visualize it, 4, 5 and 6, 7, 8 and 9. So in this 2 of 0 is 7. So 7 plus 0 of 2. 0 of 2 is 3. So the output is 10. Okay, don't make sure to make the every question is visualizable and understandable. So that's how you can easily solve it. So we get the value 10. So let us try to see. So it is 10. So compile it and check the output to verify it. So we got the output 10 here. So let us move on to the next question here. So in this they have given us a one-dimensional array. In this one-dimensional array we have a pointer and it is pointing to the first element, that is 100. So if you add this 100 plus 2, it will point to this final element, that is 200. So 200 minus the current pointing element 100. So let us check here. The current point is pointing to the array of first element, that is nothing but 100. That means we can say it as pointer of 1. So after that, the next things are pointer of 1 plus 2, that is pointer of 3, that is 200. So what we are doing, pointer of 3 minus pointer of 1, that is 200 minus 100. So we will get the output as 100. So let us check it. We got the output as 100 here. So we'll try to run this. So I'm running it. We got 100. So we will move on to the next question. So in this question they have given us a one-dimensional array. So in this one-dimensional array we have to calculate this innermost value, that means the innermost expression. After that we have to move out to the outer expressions. For that they have given a one-dimensional array with the size of 4 with this array and array of 1 divided by 2. So first, based on the PEMDAS, we have to calculate the parenthesis, that is array of 1. It is nothing but 4, 0 and 1, it is 4. So 4 by 2 will always return 2. Okay. So array of 2 is 0, 1, 2, the element 6. So the output should be 6. So see here, it's showing 4, but it is not. So let us run it in the compiler to verify it. It should return 6. So run it. So we got the output 6, that is nothing but the second index element, that is 6. So these are the 80 questions that have been asked by this Zoho interviews. So most of them were asked in the previous video, that can you explain it once again for this first pointer problem. So we will see that. So make sure to get along with that. So I'm moving on to this topic. So let us move on to the first question. Let's get up onto that. So we nearly reached it. So this is the first question. In this, we'll see how it works. So see, for this, first let us see here. They have given the values. So in this, let us open this notepad. The value of x plus plus is nothing but 5. After that, initially it is 5, but it is a post incrementation. Now x value will be incremented to 6. So I am adding after that plus plus x means it will be it is currently 6, but it will be initially incremented, so it will become 7 here. So 5 plus 7, after that, see here it is post incrementation, so we have to first add it, after that we have to increment it. So again addition, which here, see here it is pre incrementation, so we have to add it 1, after that do that. So now if we add this value, 7 plus 7 is 14 and 14 plus 9 is 23, so 23 plus 5 is 28. Okay, we got the value 28, but in C compiler it is compiler dependent for this expressions, because if we calculate from reverse, because most of the current C compilers would go based on the right to left method, in the we are going it. So let us do that. So first it is pre-incremented, that is 6, then 6 plus the current value of x is 6, let me make it. So after that we have to add post incrementation, that again 6, so the current value of x will become 7, so it is pre-incrementation, so it will become 8 now. So 6 plus 8, so again it's a post incrementation, so again we'll add 8 here, so this value will become 9 right now. So 8 plus 8 16, and 16 plus 12 also 28. So this is 28, but the evaluation orders will change and accordingly the value will be changed. That's why it is signed as compiler dependent, or we can also say that undefined behavior. See here it is an undefined behavior. So we will move on to the next one. So if we try to run this, the same question, the most of them will be stuck on this pointers because of this undefined behavior. So let us move on to this question. So see here it is like the same question here, that is 0. So let us try to here run here. In this currently it is 0, so 0 plus 1, sorry it's pre-incrementation, before that we have to store the value here. So I value is 0, so it is in post incremented by 1, so it is pre-incremented, so 2 again, so it is become 2, after that again 2. So if we try to run this, it will become 3 here, so it is 4. Okay, so it become 4 here. So if you try to run this I, we will get 8 or 10 based upon this output. So if we get back to right to left, so 1, the I value is 1 right now. So then again 1 plus again 1, so it is post incremented to 2 here, so it is 3 right now because pre-incrementation, again 3 right, 3 plus 3 6 and 8. So most of the time we will get the same value, but accordingly it is typically changed based upon the undefined behaviors because of the sequential points. So let us check in the compiler, so what we will getting. So basically you just need to print what you are getting the output, so you just need to print 8 there, so it is compiler dependent but it is printing 8, so you just need to print 8, and if you are calculating this as 28, you just need to print 28. Okay, let's move on to the next question here. In this question, let me open this notepad. So a value is 1 and b value is 2 and c value is 3. So first a plus plus, that means the current value of a 1. Okay, after that 1 plus, this value will be changed to 2. and all of them are post increment. So again it is 3 and 4, but will still remain 2 because all of them are post incrementation. So now based upon the order, it will be first multiplication will be done. So 2 multiplied by 3 will 6, 6 plus 1 will return 7. So let's see here. So we got 7 here as the result. So let us run it to verify the questions. So I'm running it. So we got 7. These are A, B, C. See here, the A value is 2, B is 3 and C is 4 and the result is 7. So let us move on to the next question here. So this is the question. In this question, I have X value as 10. After that, Y value as the current value of X multiplied by 2. And it is post incrementation, so it is increased by 1. So after that, pre incrementation, so 12, it is 12, 12 star 3. Okay, now let us calculate it. So we will get around 20 plus 36. It is 56. So let us check it. I am copying it and pasting it. So if I run it, I got 12 as the X value and Y as the 56. Y is 56. So in the next question, we will see what is the output. So let us move on to the next question. In this, if I try to paste it, first let us see what is the output. After that, we'll run. So see here, it is 8, 7 and 6, 5. In this, how it's working is because it will be stored like a stack structure. In a stack structure, first it is incremented, but 5 will be stored. So in the stack, it will be pushed down and 6 will be stored, and it is pushed down and 7 will be stored, and it is pushed down and 8 is stored. So first 8 will be printed, and after that 7 will be printed, 6 will be printed, or 5 will be printed. Or else we can, it may already done by right to left method. That is, it will be this will be executed first, and this will be executed, like that it will goes on. So these are the questions most of them are asked for. So we'll be covering most of the questions. We have recently went to IAC, so those questions will be solved, and if any interviews will be there, those questions also explained by us. So don't miss out any lives and videos. So make sure to subscribe, and then only you can watch all of the videos. So that's all for this live. So we'll be seeing on the next video. So comment for PDFs. So we'll send this question PDF to us. So we'll make another video based upon the next part of the Zoho round. So we'll see on the next round. So until then, see you guys.